Hello everyone. Let's train a customer churn prediction model now. Let's head back to classical machine learning, which can never get old. To demonstrate how quickly you can go from concept to production with our next generation AI platform. And this demo will cover not only the data science lifecycle, but also the MLOps parts. After logging into tcgmcube, we will head directly to our artificial intelligence module. Here you will see two options. Either we can create a new project or we can open the existing project. In this demo, we are going to create a new project and workflow from scratch. The project name is the only mandatory field here. So whether you are a citizen data scientist or a seasoned decision scientist, we offer a set of parameters that can help you build your project, like explainability rules, latency, throughput, which can set guardrails on which model to select. And on the left hand side panel, we have multiple options to read data from a structured, unstructured source, scheduling the final workflow, and MLOps. So let's deep dive and create a workflow. We will name it customer churn prediction model, and then I'm going to keep the description and GPU support disabled for now. And once I create this workflow, then we get a canvas where we can start the executor. Executor brings in a executor kernel in the backend, and now our workflow is ready to ready for adding new nodes. So let's start by adding read data node. It's just a drag feature, and then we will select the hyperparameters from the left hand side panel. So here we just need to select the data source. So we have a pre-configured data source, and let's hit on run button. As soon as we do it, you have seen that without writing a single line of code, we are able to read this data, and we can see the preview on the screen, where we will see basic information like row count, size of the data, all the numerical as well as categorical variables like income, and finally you will also be able to see the summary report. And this summary report contains the descriptive statistics like 5-point summary, as well as basic things like missing value. This helps me get the high level understanding of the data. Now, if I want to deep dive into data, let's add an auto EDA node. EDA stands for exploratory data analysis. Here, again, with a click of button, we can generate the complete EDA report, which will not only have the univariate analysis, but it will also have multivariate analysis. And by multivariate, I mean the correlations, interactions between variables. So now our report is ready. Let's look at it. We have overview, then we will see lots of alerts related to data. And this is kind of contextually generated already. So income is highly correlated with handset price, etc. So these are all alerts that we are getting, which can help us form our hypothesis. Then we look at individual variables like college, income, what is the distribution, what are the descriptive statistics. So for example, for overage, we will see all the quantile statistics and descriptive statistics available. Now let's move on to the multivariate analysis. So how two or more than two variables are interacting with each other. Pearson correlation coefficients, where you will see that income is again highly correlated with headset price, which is intuitive, right? So once we look at this complete report, we get a sufficient amount of hypothesis to be able to model our and choose the algorithm and model our problem statement. Now we will move, after EDA, we will move on to data pre-processing steps. So we will start with missing value imputation. Very important, because it can help you massively boost your accuracy. And we have seen that there were some missing value also available. We can also create some simple charts from the top library. You see area chart, bar chart, etc. And it's again just drag and drop functionality with some click of configurations without writing any code. Now coming to data pre-processing again. So missing value imputation is there, which we are going to do. Then outlier analysis we will be doing afterwards. So in missing value imputation, we have to just select the columns that where the missing value is present. And after selecting it, I have to select the strategy, whether I want to impute with a fixed value or median or something else. Now let's take a leap in the interest of time. So I have already added outlier analysis, feature encoding, again very important for categorical variables, data split, and our data is ready for machine learning algorithm building. So training the model. Here I am going to select classification, since this is a binary classification supervised learning problem. We will start with decision tree classifier because it is the easiest one and easiest to visualize as well. If it is a single decision tree, we can select the target variable and all the input variables that we think is independent. And then we also have either general parameter or advanced parameter, which we can hyper parameter, which we can fine tune from the left hand side panel. Once our model is getting trained and now it's ready, we will predict and then evaluate. We will do the prediction on the blind test data and then evaluation using F1 score. So here you can see the F1 score that we are getting is 0.6, not bad for a model that we are trying to create in last 5 minutes, right? And now let's try with some more algorithms because decision tree is generally prone to overfitting. So we will try with the logistic regression and also with random forest quickly. And for logistic regression, you will see that our F1 score has slightly increased to 0.63. And then I'm going to do the same step with random forest, which is an ensemble model. Again, comes out of the box in our AI platform. And here, again, let's look at the F1 score. And now you will see the F1 score is 0.698. So in last 2-3 minutes, you just have seen that how our F1 score has jumped from 0.6 to 0.7, around 0.7, by just switching the algorithms. And it's very intuitive and easy to do in our next gen AI platform. Now our model is ready, let's say, and we are ready for our champion analysis. What are we going to do next? How are we going to do the productionize this model? So we have two options. First, let's also add the node to write the data back to our database. It can be any database of your choice, which can be connected from here, and you can write the data. After you have set up the complete workflow, we have two options. Either we can schedule this workflow so that it will run every day at a particular time, or every hour. You can also schedule it. The second option, so scheduling is very easy. Again, you don't have to write any cron jobs, any code, just select some features and you are good to go. Next option is the creation of API, where you want to use the model serving in the real time. But before we go there, I will also show you our MLOps library that we have just integrated, where you can have a complete track of all the models that you have trained. So in last 7 minutes, I have tried 3 different models and all these models are saved here. I can go to this interface and compare these models metric by metric to be able to understand. So here I just used F1 score in the interest of time. For your use case, you may have to use precision, you may have to use recall, etc. After you compare the model, then you will select which model is the best. You already have got some indication on our front end application using evaluate node. And after you are ready, you can register the model in our model registry. So then this model version will be tracked. So every time you are going to update this model. And why we need this model versioning? Because we want to not only deploy the model and leave, we want to keep tracking the model for its accuracy, for its model drift, for its data drift, and all those things are inbuilt in this module. So let's register the model, providing our model name, and then we will again, after registering, we will head back to our, we can download the pickle file from here in our local, so that we can again upload it and create the Docker image in the backend. So again, in case of creation of Docker image and productionization, we don't have to write any code. It's just one touch production ready application. Here I'm going to give my API name, upload the pickle file from my local machine, and if I can put requirement.txt if I am using some custom libraries from Python, which is not natively available out of the box in our environment. Once we deploy it, we have to just click on run. Now our service is ready to be used. So we have two URLs here. One is to get the schema and the second one is to predict. So for any system to use my API, they will need to know the API signature. And here this is my local machine, Postman. Using Postman, I have called the get schema API and I am able to get the schema. What all variables are required, like average, call overage, and other variables are required to get my prediction. So now I have to call the other API, which is my predict API. And here I have to put some value in these fields, right? Average call duration, headset price, house, income. So I'm going to put some value. I have some intuition about what my customer data looks like. Those value I'm going to fill, and just I have to click on send button. What it is going to do, it is going to call the API that we have just deployed, and then we will get the final prediction. So now let's fill this up and click on send button. Okay, so here we are getting an error because I have selected get. This is a post API, so I have to correct it, and then we have our prediction that this particular customer has probability of leaving, right? So as promised, we demonstrated how quickly you can go from start to production with our generative AI module.